You guys are welcome to another great section of this great tutorial class. We are super excited to see you guys once again. And please ensure you follow our classroom. Don't disturb yourself, don't distract yourself by any means. Ensure you watch this video from the beginning to the end so that you get the full details of everything we'll be dashing out in this section of our classes. And ensure you follow up our classes regularly so that at the end you have a good story to tell. I know that you are going to gain a lot from this class already, so please ensure you follow us and avoid distractions. Again, if you know you are not subscribed to this channel, please try and do so now, because the more you subscribe, the more we'll have the energy to do more videos. Thank you very much as you do that. So today, we are going to be discussing a very important aspect of physics, which is an aspect of electricity that we call static electricity or electrostatics. Now, electrostatics, what do we mean by electrostatics? Then we are still going to look at electric current or current electricity after this aspect of this physics we are looking at now, current electricity physics, which is the electrostatic aspect. That's what we are looking at now. Now, what is electrostatics? Electrostatic is the study of charges at rest. When charges are not moving, when we are studying them and they are at rest, we call that phenomenon electrostatics. And one of the major things in electrostatic is this charges we are talking about. And what is a charge? Or what is the meaning of a charged body? When we say a body is electrically charged. Now listen to this. Electrically charged bodies are bodies that can exert electric forces on the surrounding objects. Electrically charged bodies are bodies that can exert electric forces on the surrounding objects. And these bodies or these charges we are talking about have different properties. They have different what? Properties. Now, property one, properties of charges. Take it down. Properties of charges. Now, property one. The first one is that they exist in two forms. What I say? Charges exist in two forms. Now, if I say a body is electrically charged, that electric charge exists in two forms. Or the electrically charged bodies can be presented in two forms, which can either be, this charge we're talking about can either be a positive charge or negative charge. It can either be what? A positive charge or what? Or negative charge. That is why I can define electric charges as the characteristics of a unit of matter which something like expresses the extent to which this body has what? More or fewer electrons than proton. Now, when a body has more of electron than proton, we say this body is negatively charged. If you have something like fewer electrons than proton, that's why this body is positively charged. You can put the charged body that way. But electrically charged bodies are bodies that exert electric forces on the surrounding. Now, these charges, property one is that they have what? They exist in two forms. They can either be what? Positive or what? Negative. Now, look at me, what proves it positive. If a charge has this sign, plus sign, we say that this charge is positively charged. If it has minus sign, we say this charge is negatively charged. That's what we say. So this is the positive charge, this is the sign of the negative charge. So this one is positive, that's positive, that's positive, then this one is negative. It's negative. So please take note of that. It is very, very, very important. It's very, very, very important. Now, property two. Two like charges will repel each other, while unlike charges will attract each other. Like charges will repel each other, while unlike charges will attract each other. Now, what do I mean? I'm trying to tell you that if two charges are like, what do you mean of like? If they are the same in form, or if their signs are the same, if they are negative, or positive, they are called like charges. For example, this and this are called like charges. We call them like charges. Then these two, which is this positive and negative, this one is called unlike charges. That's what we call this one. This one is called like charges. Why this one is like charges? Then these and these are still like charges. If the signs in the charge or if the nature of the charge is the same thing, if this one is positive, the other one is positive, they are called like charges. But if one is negative, the other one is positive, or one is positive, the other one is negative, they are called unlike what? Unlike charges. Now, two like charges, this and this will repair, this and this will repair, this and this will attract, this and this will attract. What do you mean by repair? We tend to push each other away. What do you mean by attract? We tend to come close to each other. Now, this and this will tend, if I look at these two charges, if I look at the force between them to be something like a repulsive force. Before the repulsion will go this way, both of them will be running away from each other. What about this and this? They will be coming closer to each other because two like charges will repel, while unlike charges will attract. Like charges what? Will repel, while unlike charges what? Will attract. Probability. Charges are conserved. Charges are conserved. Charges are conserved. Now, what's the meaning of charges are conserved? This means that the algebraic sum of all charges in an isolated system or in the universe, it can be is constant. Is what? Is constant. The algebraic sum of all the charges in an isolated system or in the universe is constant. This is telling us that charges can be conserved. There's what? Can be conserved. There's another one. Probably four. Charges can also be quantized. Charges can be quantized. Take a look at that. Charges can be conserved. Charges can be quantized. Now, what do you know that? What do I mean by charges can be quantized? Now, this means that any charge found in nature can be written as Q is equals to NE. Any charge found in nature can be written as Q is equals to NE. Now, what is the meaning of that Q? Q is the charge. Q is the symbol for charge. Then N is any integer. It can either be a positive or negative integer. That's N can either be a positive or negative integer. But whatever E is called elementary charge. What do I call it? Elementary charge. That's what we call E. Is the elementary charge. And the value is that E is equals to 1.602 times 10 to the power minus 19 coulomb. Minus 19 coulomb. This one is coulomb. Where coulomb is the unit for charge. Take a look at that. Coulomb is the unit for charge. So the charge of the something like this E is 1.602 times 10 to the power minus 19 coulomb. That is the elementary charge. It's not electron. So people think that it's electron. It's not electron. Now we have some atomic particles. What we call neutron. What we call proton. What we call electron. Now, what is the charge of electron? The charge of electron is minus E. The charge of electron is minus E. While the charge of proton is plus E. Now, what is the meaning of this E? This E is not electron. That E is called elementary charge. That's what we call it. And the value is 1.602 times 10 to the power minus 19 coulomb. I can say the value of electron, the charge of an electron is minus 1.602 times 10 to the power minus 19 coulomb. I can also say that the charge of a proton is plus 1.602 times 10 to the power minus 19 coulomb. Those are the charge. What about neutron? What kind of neutron? Neutron is neutral. Neutral. Now, what do we know of neutral? Now, we are going to move to another dimension now. What we call neutral bodies. Neutron want to move on to another dimension. Neutron want to move on to another dimension. Now, let's go to that place. Neutral. Now, when is a body neutral? We said a charged body is a body that can give electric forces to the surrounding. Now, when do we say a body is neutral? Now, when is a body neutral? A body is neutral if it has no charge. Take a look at that. A body is neutral if it has zero charge, or a body can be said to be a neutral body if it has equal amount of positive and negative charge. Let's say a body has plus 2 coulomb and also have minus 2 coulomb. It has plus 2 coulomb and minus 2 coulomb. Now, if you look at the total charge, what is the charge inside this body? Plus 2 and of course has 0. Plus 2 and 2 give us 0. So the body has no charge. It has 0 charge. So a body that has 0 charge or a body that has no charge is called a neutral body, or a body that has equal amount of positive and negative charge is a neutral body. Then if you have more positive than negative, we say a positively charged body. If you have more negative than positive, we say a negatively charged body. Now, these bodies that are neutral, can we charge them up since they have charges inside? but the two charges are the same thing in magnitude, but this differently signed. Now, can we charge them so that they will not be charged? Yes, we can charge them. There are ways of charging a neutral body. Take note of this: ways of charging a neutral body. Another important subheading: ways of charging a neutral body. Now, what is a neutral body? We said the neutral body is a body that has no charge, or a body that has equal amount of positive and negative charge. Take note of that. Now, how do we charge this neutral body? Now, there is something we call charging by friction, and there's something we call charging by induction. That's what we're going to be looking at in these two things. Now, any charging of a body you are going to come across in life is either going to be either by friction or by induction. The one they call something like by conduction, the body is still going to be in contact with each other. The one is also called contact friction. Have you heard about that before? Contact friction. But it's still something like there is still friction between them. Even though the thing is now charged by conducting. Not, you are not something like rubbing them. Now, mainly charging a body by friction is the act of rubbing about two bodies, two dissimilar bodies, two dissimilar neutral bodies. Take note of that. Is the act of rubbing vigorously two dissimilar neutral bodies. It thought that at the end of the day, both of them will be left with unbalanced charge. Now, charging a body by friction is the process in which two bodies are rubbed together vigorously. So that at the end of the day, both of them will have what? Unbalanced charge. Example is when you rub a plastic comb with your hair. Now, most of us do comb our hair. Now, if you are like rubbing a plastic with your hair, now the hair will acquire a charge at the end of the day. Then the plastic comb will acquire a charge at the end of the day. Now they can ask you, if a comb is rubbed with hair, therefore at the end of the day, the comb will be dash charged. Now, if a comb is rubbed with hair, at the end of the day, the comb will be negatively charged and the hair will be positively charged. Why? Because excess electron will leave the hair and enter the comb. Now, if the hair now loses electron, then we will not have more proton than electron, it will be positively charged. Then the comb will not have more electron than proton, it will be negatively charged. Remember, electron is negative, proton is positive. So, when you rub a plastic comb with your hair, at the end of the day, your plastic comb will be negatively charged, while the hair will be left positively charged. Another one can be when you rub rubbing a glass one with silk, and so on. So please, assignment one. Go and get 4 cases or 4 examples of charging a body by friction. When you rub two bodies together, two dissimilar bodies. Because there are some bodies that love positive charge, there are some that love negative charge. You carry the one that love positive, carry the one that love negative, you rub the two, they will take the one they love from each other. Then at the end of the day, we will have more positive and negative, we also have more negative and positive in the other one. So that one will be positively charged, the other one will be negatively charged. So please look at 4 examples of charging a body by friction. 4 examples of charging a body by friction. And also go and look at for me, what is the meaning of tribal electric charging? Tribal electric charging. There is something called tribal electric charging. I've been mentioning these things. Go and check the meaning of that. Because I'm trying to give you guys assignment. I know you will have work to do. You have work to do. Now, also charging a body by induction. Now, how do you charge a body by induction? How do you charge a body by induction? How do we charge a body by induction? Now, charging a body by induction means when you something like take a neutral body close to a charged body, or when you take a charged body close to a neutral body, and at the end of the day, you will not both of them will not touch each other. Let's say you have this body, you have this one. One of them will be X. Then one of them must be charged. Then if you take it closer to this neutral one, at the end of the day, this neutral body will acquire the opposite charge of this charged body. So this process is not charging by friction because they are not touching each other. They are called charging the body by induction. Charging the body by induction. There was what we call the types of materials we have in physics. In electric physics, we have material that we use. In electronics, we have material that we use. In electric content, we have material that we use. So types, all these materials, we group them into different types electrically. Now, number one, what we call conductors. We have what we call conductors. Now, what is the meaning of conductors? What do we mean by conductors? We have what we call insulators. We have what we call semiconductors. We have what we call superconductors. Now, what is a conductor? A conductor is a material that can conduct electricity. A conductor is a material. Guys, we are talking about electric conductors, so not just any other conductor. Now, big conductors. We are not talking about it. We are looking at electricity. Now, take note of that. In electricity, a conductor is a material that can conduct electricity, that has free charge carriers. Electric charges can pass through freely. We call them electric conductors. They can conduct electricity. Examples are we have iron, copper wires, aluminium, etc. Most of the metals we have can conduct electricity very well. Even your water can conduct electricity. Most of the stuff like every like wood that has water inside, living woods, they can conduct electricity. So conductors are materials, although we have poor conductors, we have poor heat conductors, yes. But materials that conduct electricity are called conductors. We have insulators. Insulators are materials that cannot conduct electricity. Any material that don't conduct electricity or that cannot conduct or that don't have free charge carriers. Materials that don't have free charge carriers are called insulators. Take note of that. Materials that don't have free charge carriers or that can conduct electricity at the lower state is called we call it insulators. Now some people do say insulators can conduct electricity. Look at it. If you convert and if you alter the body condition of an insulator, there is something that made it to become an insulator. If you alter it, if you alter those things, and the thing will not be able to conduct electricity automatically, you have moved the material from an insulator to conduct. When we say insulator, it means it cannot conduct that thing. It cannot conduct it. When we say heat insulator, remember when we were doing the thermoflash, we have put heat insulators at collide between the edge of the inner to the outside, so that it will not pass through that one. So if you can alter an insulator, if you can alter the body temperature of an insulator, and the insulator will not be conducting electricity, automatically it can become a conductor. A conductor will be something that can conduct. Insulator will be something that cannot conduct. Take note of that, it's very important. Example of insulators can be all this rubber, plastic, etc. If you look at most of the wires we use at home, all of them, they have rubber wires around them. Why? Because they are trying their best. We use insulators mostly to separate the conductor from the external environment in order to be practicing safe practice. Because you cannot just use all these wires we use in overhead wires and what you call it, or naked wires to connect your homes. It's not possible. If you try it, you are in danger of electric shock. You are in danger of electric shock. And if the electricity shock, it can kill. Electricity can kill. Depending on the rest. So that's how we use it. We use insulation mostly to separate the conductors from the external environment. That's why some of us, even though there's electricity, electric current flowing through wire, we touch the rubber, we will not get shocked or we will not experience an electric force because the thing has been insulated from the surrounding. We use insulators for that and others. Then we have what we call semiconductors. Now what is a semiconductor? A semiconductor is a material that is intermediate between a good conductor and insulator, or between a conductor and insulator. Now the material that is between a conductor and insulator, it is not fully a conductor, it is not fully an insulator, we call them semiconductor. They are semi-metals that are not fully metals, they are not fully non-metals, they are just between them. Example can be germanium, gallium, even silicon can be said to be a semiconductors, and so on. We call them semiconductors. Mostly we use them in electronic physics. In electronics, studies we use them there. So please take note of that, they are very, very important. And a semiconductor has a negative resistance of the conductor. Also take note of that. A semiconductor has a negative resistance of the conductor. In more of this class, we'll be discussing more when we get to resistance in current electricity. I will explain that so that you see it. I will explain that going something like the movement of the resistance of the semiconductor with temperature. Remember, a platinum wire can be used as a platinum resistant thermometer because if the temperature is decreasing, the resistance will also increase for a platinum wire. That is something like actually a semiconductor, that is a conductor. But what if I say a semiconductor have a negative resistance of the conductor, it means if the resistance in the conductor is going up, the temperature for that the semiconductor will be going down. because they are negative to each other. They are negative to each other. Because of time, we'll not be going there or going far to that place. But most of our classes, we are going to look at all those things. Now, we have superconductors. Superconductors are materials that have absolute zero resistance to the flow of current. Superconductors are materials that have absolute zero resistance to the flow of current. Now, we have shear theories in electrostatics. Shear theories for electrostatics is spherical shear of charged bodies behave as though the charged bodies are considered at the center. So please look at all those shear theories that I just quoted. And please, what's what we call Coulomb's law? What we call Coulomb's law. Coulomb's law. Now, look at something. We said like charges we repel, or like charges we attract. Now, when we are solving electrostatic force, especially when we are using what we call superposition principle, those two statements stand well. Those two statements are going to help us well. So put those two statements in your head. That two like charges will repel, two unlike charges will attract. Put them in your head. They are going to help us very well. Now look at it. Let's look at this Coulomb's law. Now Coulomb's law. Coulomb's law states that the force of attraction or repulsion, between two charged bodies is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of their distance apart. Coulomb's law states that the force of attraction or repulsion between two, take note of that. It's not 2. Please, you can call this one Q1, you call this one Q2, call this one Q2. And we don't know their charge. They can be positively charged, they can be negatively charged. That does not concern us. What concerns is that they must be two. Look at their line of action, the line of action of the forces, their distance from here to here. Measure from this center to this center. Then let's go this out. So that is the force of attraction or repulsion between two. Take note of that two. Between two charged bodies, not any half body. Between two charged bodies is directly proportional to the product of the charges and inversely proportional to the square of their distance apart. Coulomb's law states that the force of attraction or repulsion between two charged bodies is directly proportional to the product of their magnitudes and inversely proportional to the square of their distance apart. Take note of that. Now, mathematically, this was saying that the force F of attraction or repulsion between two charges is directly proportional to the product Q1 times Q2. Let me remember that in mathematics is product is times of their magnitude. Look at the magnitude. So the magnitude of the two times shows that you are taking magnitude of the product of the magnitude of charges and inversely proportional to the square. Inversely means over to the square of the distance arrow to the square of that distance apart. Now, if you want to write this equation very well, you will introduce an equal to sign to become the log that become an equation. Yes, you are not having an equation because it's not equal to sign. The other day, if you take this sign and write the equation, then you will insert a constant k. You insert a constant k there. Then you must have Q1, Q2 over R squared. Now the value of magnitude means size. Size without sign. For example, we have plus 2 Coulomb, we have minus 2 Coulomb. If I want to put them here, we know that these two charges are going to attract each other. Why? Because they are unlike charges. They have different signs. So they are unlike charges. They are going to attract each other. So if you want to put them here to calculate problem for the force, don't put the signs with them. And don't put the signs with them. That will help us very well when we are doing the superposition principle. That's how you calculate forces as is between charged bodies that are not more than 2. Let's say 3, 4, 5, and so on. How the superposition principle to analyze the issue. So, but unless you're using vectors, some people are using vectors method, they do put the direction as well. But when we're using this main method I'm talking about, from the directly from the definition to the product of their magnitude. So you just take the magnitude. So remember that any magnitude. So in most sense, we can also see this way. Okay, Q1, Q2 over R square. You are not going to see 2 slash there in most sense. But note that this is the magnitude of the 2 charges. That's why you are taking there. Take note of that. It's very important. You're going to take the magnitude of the charges. And what's the meaning of F? F means force. This F means force. Now you have force in Newtonian physics, like F follow MA from Newton's laws of motion. We also have force from Coulomb's law. We call it Coulomb force or electrostatic force or electric force. That is the F that's in there. Coulomb force or electrostatic force. Take note of that. Then we also have K. What is your K? What is your K? Let's do K first, but we are going to define K very well. Now let's go to Q1. Q1 is the first charge. What about the other one? Q2. What is Q2? Q2 is the second charge. Take note of that. Q1 is the first charge. Q2 is the second charge. Then arrow is the distance between both of them. That's R. Arrow is the distance between the two of them. Their distance apart is called R. Now what is K? K is called constant of proportionality or electric force constant or Coulomb force constant. Coulomb force constant. And K is equal to 1 over 4 pi epsilon naught for air. Why? Because there are what we call mediums like air, water, oil, some solutions. There are mediums in which you can perform an experiment. And all these mediums are what we call dielectric constants that affects this K directly by multiplying this E naught with the dielectric constants of that medium, because this E naught is called permittivity of free space. Permittivity of the free space you have. Now, if that space have a dielectric constant that is greater than 1, because for air, the dielectric constant is approximately 1. If you have a dielectric constant that is greater than 1, then you now see K to be equal to 1 over 4 pi epsilon arrow, epsilon naught. Where this epsilon arrow is called relative permittivity, which is the dielectric constant of the medium you have. For air, this dielectric constant is 1. That's why for air, we won't put this on there. For air, we won't put this, we remove it, and we'll have this. And if you have this is approximately equal to 9 times 10. Okay, let me say 9.0. Look at 9.0, it's no pressure here. Times 10 to the power 9. 10 to the power 9 Newton meter square per Coulomb square. Newton meter square per Coulomb square. That's the value of K approximately for a medium is air. It's a constant value. Then what is the meaning of epsilon naught? What is the value for epsilon? Epsilon naught is 8.85, approximately 8.85 times 10 raised to the power minus 12. 10 raised to the power minus 12 Coulomb square per Newton meter square. Coulomb square per Newton meter square. Please take note of that. It's very, 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 very important. Now, how do we solve problems in this using this Coulomb's law? Now, let me give you a question. Give you a problem in physics. Obtain the electrostatic force. You write. Obtain the electrostatic force. We're going to start from here. Then we are going to round up this question now. In our next class, we are going to be looking at mainly Coulomb's law and superposition principle. Coulomb's law and superposition principle. In that place, we will now be looking at if you have more than 2 charges, how do you resolve the forces that exist between them? That's what we'll be doing there. So please ensure you join us in that class. But let's finish up this on top of time. Now, let's call this question out. Obtain the electrostatic force. What is not electrostatic force? This F that's in here is called electrostatic force. Obtain the electrostatic force that exists between charges. 2 microcoulomb and 10 microcoulomb. Obtain the electrostatic force that exists between charges 2 microcoulomb and 10 microcoulomb separated by a distance distance of 2 centimeters. Separated by a distance of 2 centimeters in air. Separated by a distance of 2 centimeters in air. In what? In air. Calculate the electrostatic force that exists between charges 2 microcoulomb and 10 microcoulomb. Separated by a distance of 2 cm in air. How do you calculate that? Now, what is the value for our first charge? Okay? Now, if the charge don't have sign, it's a positive charge. Take note of that. You can also see this way. Plus 2 microcoulomb and plus 10 microcoulomb. They are positive. They are positive. Then, if you are making the number take positive, if a number don't have sign, let's say 10. This 10 is plus 10. It's a positive number. Most numbers don't have signs with them. They are positive. Assume them to be positive. But numbers that have negative sign with them, they are negative. They are always negative. A negative number will always carry that negative number. So this number is a negative number. Take note of that. So we have the Q1 to be plus 2 microcoulomb. We set it as plus 2. Now in physics, what is of micro? Micro means this micro that's in there means 10 is a value, is a prefix given to a magnitude or a value that is 10 raised to the minus 6. That's the other micro. Then coulomb. This coulomb is the unit for charge. So this coulomb is this coulomb. This micro is it 10 raised to the minus 6. Then this 2 is this 2. Why are we converting? Because from this our constant, what we have is coulomb, not microcoulomb. Take note of that. So we must ensure we move everything to 610 international or the standard unit. Now what about K2? K2 is 10 microcoulomb. Now, what is the number 10 microcoulomb? Plus 10. And what is micro? Micro means 10 raised to the minus 6. And what is the coulomb? Coulomb is the unit for charge. Put it there. Then what is the distance between them? The distance between them arrow is 2 cm. 2 cm. 2 centi. What is 30? 30 means 10 to the minus 2. That is the prefix used for 10 to the minus 2. You value 10 to the minus 30. Before you can just say 2 10 to the minus 2 meters. Or you just say, if you want to go from centimeters to meters, you divide it by 100. And it will give you 0.02 or 2 times 10 raised to the minus 2 meters. I don't know if you can get that. It's very, very simple. Look at what I'm trying to say. Look at what I'm trying to say. This 30 means 10 to the minus 2 in physics. So you just have micro means 10 to the minus 6. 30 means 10 to the minus 2. So you put 30, you put 10 to the minus 2, then you have this directly. That's what I'm trying to say. Now, if you now move everything to this formula, what's the electrostatic force? Electrostatic force is F is equals to Q1, Q2 over R squared. Now this is what is K? K is the Coulomb force, because now this is 9 times 10 to the 9 times what is Q1? 2. You don't put the values again. Why? Because you are not using their magnitude. You don't put the signs, not values. You don't put the sign, their signs again. You don't put the values hold, not the signs to them. That is the magnitude. So you throw away the sign and put only the value. 2 times 10 to the power minus 6 times 10 times 10 to the power minus 6. Someone will ask, what about those that don't have a sign at all before? Use them like that. If they have sign, if you want to use them before that, throw them away. Now the sign is going to tell us that these two, the electrostatic force is going to be a force of what? Repulsion, not attraction. Why? Because there are two like charges. That's what the signs are telling. That's what the sign used to tell us. It tells us the nature of the force is going to be. Take note of that. So divided by the distance is 2 times 10. This power minus 2 squared. So this will give us 9 times 2. What is that one? That will give us 18. Then we have 10 to the power 1 here. We have 10 to the power 9 times 10 to the power 1 times 10 to the power minus 6 times another 10 to the power minus 6. That is, you pick one of their base. Because for multiplication, if you have 2 numbers, 3 numbers, 4 numbers, a to the power n times a to the power n. That would be a to the power n plus n. Pick one of the bases and add power. Even though they are a to the power into how many bases? Pick one of the bases and add up their power. You still work. So we're going to pick one of the bases here. We have 10 here, we have 10 here, we have 10. We pick one of the because multiplication all true. Then we pick one of them and add up their power. We have 9 plus minus 6 plus this 1 plus minus 6 again. Then divided by 2 raised to the power 2 give us 4 times. Then if you have double power in indices, you know we are going to look at our indices class. Go back and look at it. It's very important. We use mass, and in physics we use mass. Even chemistry we use mass. In science we use mass. Mass is our language. We use this, and mass is our native language in science. So you have to know the native language. You have to know the native language, which is mass. It's very important. So you have to find minus 2 times 2, that will give us minus 4. So the next thing we have 18 times 10 this far. Now plus times minus will give us minus. Plus times minus will give us minus. Take note of this. Plus times minus is equal to minus. Plus times minus times plus is equal to minus. Plus times plus is equal to plus. Minus times minus is equal to plus. Take note of that. It's very, very important. It's very, very important. Then that's why this those give us minus 1. So 9 minus 6. Okay, that's why this 6 minus 6 minus 6, that's minus 12. Minus 12 plus 1, that's minus 11. Minus 11 plus 9, that will give us minus 2. Or 9 minus 6, that will give us 3. 3 plus 1, that will give us 4. 4 minus 6, that will give us minus 2. Over 4 times 10 raised to power minus 4. So this will give us, we have 10 raised to power minus 2 divided by 10 raised to power minus 4. I already told you guys that if you have look like this, if this one moves up, if this minus 4 moves up now, the sign will change from positive to negative. Remember that? I told you guys that. So we're going to have 18, we have 2 here, 9. 2 here, 2. We have 9 over 2 times 10. Pick on the base, this 2 base. Pick on this 2 base. And you can also pick on the base and subtract their power. You can also say 10 raised to power minus 2 plus. Okay, minus and plus is division. Division is minus. A raised to power m divided by a raised to power m gives us a raised to power m minus n. Can you remember that? So 10 raised to power minus 2 divided by 10 raised to power minus 2 plus 10 raised to power minus 2 minus 4. Minus 4. Minus cannot give us close. So you don't waste time. I already explained to you guys. If this power, as far as the 2 goes is the same, this power will now move from the sign will change. That will change to from minus 4 to plus 4. Then we have 9 over 2 will give us 4.5. That will give us 4.5 times 10 to the power minus 2 plus 4 will give us 2 newtons. Or you can write it this way: 4, remove this point, 4 2 times. That's 4 5 0, that's 450 newtons. That's what I know about. So then you have 4.5 times 10 to the power 2 newtons or 450 newtons. That's what I know about. Now, in case of a fast, you are very fast in solving, you can use your calculator to run the problem directly from there. You see there 450 newtons. That's what you can have. So please ensure you don't play with this class. It's a very important class. As far as electrostatics is concerned. I shall have a very great history about charge, how to test for positive and negative charges, instruments used for testing positive and negative charges. Some instruments we have in electrostatics. Please try and look at them, something like Goldleaf, electroscope, and the rest. Try and look at them. It's very, very important. God time, we're going to be watching this class in this place. Remember in our next class, we're going to be looking at how to solve forces that exist between charges, something like bodies, charges that are not, something like this. You have to look like this. You have charge here, you have charge over here, you have charge over here. And this is the line of the action. Then this one is positive, negative. Let's say this one is 10 microcoulomb, 20 microcoulomb, or 30 microcoulomb. This one is negative 30, negative 20, negative plus 10. How we solve? How we calculate the force of this? How we calculate the force of this? How we calculate the force of this? That's what we're going to be looking at in our next class. And it's Coulomb's law and superposition principle. Superposition principle helps us to Coulomb's law. Look at this. Let me give you guys an introduction. Now, Coulomb's law is telling us the force that exists between two charge bodies. Now, this superposition principle we are talking about in electrostatics will now help us to apply this law when we have more than two charges. It will now show us what to do. Thank you guys. See you guys in our next class. God bless you.